Good morning, folks. Hopefully you're doing well. This is Mike coming back at you with another video on precalculus. In the previous video, we began to talk about trig equations and a couple techniques we'd have to use to solve them. In this video, we are going to wrap up our discussion of solving trig equations. So, sometimes we may see trig equations that are in a quadratic form. We solve them in basically a similar kind of way as to what we saw at the beginning of our previous video. But first we just want to make a small substitution, just to make things at least look a little bit nicer. So here's a sample problem, and we'll do a couple more after this one. So suppose you have to solve 2 cosine squared x plus cosine x minus 1 is equal to 0. Again, we want all positive angles that are less than 2 pi. And they can be 0 as well. So we're going to make a small substitution before we go on to solve this. We're going to let u equal cosine x. So when we make that substitution, when we let u be cosine x, we get 2u squared plus u plus u minus 1. And this is a nice quadratic. This is a lot friendlier to look at. It's a lot friendlier to try to come up with the factors that we need. If you factor 2u squared plus u minus 1, you get 2u minus 1 and u plus 1. And this is equal to 0. We can now substitute back in for u. And since the product of these two factors equals 0, that means either one of these factors can be 0. So we have 2 cosine x minus 1 equals 0, or we have cosine x plus 1 is equal to 0. Solving of this guy for cosine x gives us cosine x has to be 1/2. Solving this guy for cosine x is equal to minus 1. So we need to find the angles, or the x values, such that if you plug them into cosine x, you get either 1/2 or you get -1. Well, solving cosine of x equals -1, pretty easy, pretty straightforward. There's only one angle that will make that true, and that angle is pi. Cosine of x equals 1/2. Cosine is positive in quadrants 1 and 4. The angle in quadrant 1 that makes cosine of x equal to positive 1/2 is 60, or pi over 3. So we need the angle in quadrant 4 that has reference angle pi over 3, and that angle is 5 pi over 3. So we have our 3 solutions here: pi over 3, pi, and 5 pi over 3. A solution to either one of these two equations right here is a solution to our given problem. So let's try a couple more here. First one, cosine squared x minus 1 is equal to 0. If you take a look at the left-hand side here, what we actually have is a difference of 2 perfect squares. So you can make the substitution here. Let u equal cosine x. Then this becomes u squared minus 1 equals 0. This is now more clearly a difference of 2 perfect squares. Really straightforward to factor this. U plus 1 times u minus 1 equals 0. And then substitute back in. So I get cosine x plus 1 times cosine x minus 1 equals 0. And now set each of these factors equal to 0 on their own, and solve for the trig function. So we're going to get cosine x equals -1, or cosine x equals positive 1. Well, we just saw that the only angle that makes cosine x equal to -1 is pi. So that's our one and only angle that makes this guy true. What angle or angles make this guy true? Well, if you think of the values of our functions from our handy dandy little chart there, the cosine of 0 is equal to 1. And no other angle that is less than 2 pi and greater than or equal to 0 is going to make it 1. So in this case, we only have two answers, 0 and pi. I'm going to challenge you guys on this one. Try to solve this guy on your own. Try to solve tan squared x minus tan x is equal to 0. So pause the video here, try to solve it. Once you come up with the answer, press play, and we'll see if you were correct. Once again, we want all solutions greater than or equal to 0 and strictly less than 2 pi. All right, so let's see how we get to the correct answer. I'm going to make the substitution. I'm going to let u be tan x. Then this thing becomes u squared minus u, or pulling out the common factor of u times u minus 1 is equal to 0. So this means tan x times tan x minus 1 is equal to 0. And again, product of two factors equaling 0, that means either factor can be 0 on its own. So tan x equals 0, or tan x minus 1 equals 0, which means tan x is equal to a positive 1. Okay, let's come up with some x values here. Let's try to think of all the x values such that when we plug them into tangent, we get 0. Well, tan x is sine x over cosine x. So tan x will equal 0 when sine x is going to equal 0. So what angles greater than or equal to 0 and less than 2 pi will make sine of x equal to 0? Those two angles are going to be 0 and pi. So that takes care of the first equation. We solve the second one here. We need the angles x such that when you plug them into tangent, you'll get a positive 1. Tangent is positive in quadrants 1 and 3. The angle in quadrant 1 that we plug into tangent to get a positive 1 out is pi over 4. So that means we need the angle in quadrant 3 who has reference angle pi over 4, and that will be another solution. The angle in quadrant 3 that has reference angle pi over 4 is going to be 5 pi over 4. So there we go. Those are our 4 solutions to this trig equation right here. Tan squared x minus tan x is equal to 0. So those were just a couple sample problems there. One more thing I want to mention is with some of these trig equations that we just solved, where you may have a quadratic or something like that, it may not be given to you in that nice quadratic form. It may be given to you where you have terms on each side. And as we saw in the previous problem, you may have to factor, but if you have the same factor on each side of your equal sign, you do not cancel out a common factor. Because if you cancel out the common factor, then you are removing valid answers to that given equation. I provide a sample here. If you had tan x times sine squared x is equal to 3 tan x, if I canceled out the tan x's and just left sine squared x is equal to positive 3, then I wouldn't have any solutions, because there's no angle that I can plug in to the sine function such that if I get that value and then I square that value, I'll come up with a positive 3. The largest and smallest values that the sine function can have are -1 and +1, and square those things, you're just going to get 1. So if you canceled out the tan x, then you would not have any, or you would claim that there are no answers to the given trig equation. But that's not true. There actually are answers. What you have to do is you just have to move everything onto one side and then pull out the common factor and then set each factor equal to 0 and then solve for x. And you see here, if you read through this problem, that our two solutions are 0 and pi. Something you may have to try at some point is using one of our trig identities, double angle formulas, sum and difference formulas, things like that. Just one quick sample here. If you saw sine x times cosine x equals 1/2, usually a sign that there's something you have to pull is when you're taking the product of two separate kinds of trig functions just equaling some number or something kind of like that, or just some funky looking kind of thing. But for the most part, the types of questions you'll be seeing are basic ones, ones where you have, say, 2x or 3x, and then quadratics, something where you may have to pull a factor out or factor the thing down. So guys, this concludes our video here on solving trig equations. If you have any questions or comments, please be sure to reach out to me. Send me emails, texts, leave voicemails, postcards, whatever you have to do. Otherwise, until the next video, take it easy, guys.